Hello students, this is day 2 of 8.1, average value of a function over an interval. This is your main notes for today, and you probably had this written down from the first video, really, but the average value of some continuous function f on the interval from a to b is that definite integral from a to b divided by b minus a. This is how you find an average. You divide by basically how many you have, right? So from A to B, that's how many we have. So we are going to do 4 example problems, and then I will tell you what the homework is. All right, pretty classic problem. We're just asked to find the average value of our function. First off, is the function continuous on the interval 4 to 6? Yes. Okay, the only time that this function would not be continuous would be at 0. Cool. All right, so let's find the average value. By definition, that average value is 1 over b minus a times the definite integral from a to b of our function. So this gives us 1/2. And then the integral of 1 over x is ln x. So it's 1/2 ln x. Now it's technically the natural log of the absolute value of x, but as we can see here, I'm only plugging in positive values anyway, so I'm just not going to put the absolute value. And then we want to evaluate that at 6 and 4. All right, so that gives us 1/2 ln of 6 minus 1/2 ln of 4. Now, if this is a multiple choice question with natural log, I think the harder part is really like remembering your properties of logs. So what I'm going to do is factor out the 1/2. So of ln 6 minus ln 4. And if you remember your properties of logarithms, right, if we subtract 2 logs with the same base, these both have a base e because they're both ln, we can just rewrite this, of course with the 1/2 out in front, we can rewrite it as a single log of division. Similarly, if this was a plus sign, we could write it as a single ln of 6 times 4, ln of 24. But it's minus, so we can write it as a single log with division. And then our final answer is 1/2 ln, and then we can simplify to get 3 over 2. Now I got this from a no calculator problem from AP Online, and this is how the answer was written. If it wasn't a multiple choice question, you could kind of leave it at any various state that we've been solving the problem, like this is fine, this is fine, this is fine. This is just what the final answer was for AP Online. And just, again, the harder part of this problem is probably the logarithmic property. Okay, the velocity of a particle problem, the one that you will definitely see. All right, so this one here, we want to find the average velocity, so that's just the average value of our velocity function from -1 to 2. First off, is our function continuous on that interval? Yes, our function is just some cubic polynomial, therefore it's continuous everywhere, so it's definitely continuous here. And so our average velocity or average value is going to be 1 over, all right, 2 is b, -1 is our a. So 1 over 2 minus -1 times the integral of -1 to 2 of our function, 3t cubed minus t squared dt. Okay, so this is 1/3. And then let's do our entire integral here. Let's take, let's antiderive this. So we'll have 3/4 t to the 4th, and then minus 1/3 t to the 3rd. And we want to evaluate that at 2 and at -1. Okay, so I'm just going to leave the 1/3 out in front until the end, really. Okay, so I'm going to first evaluate at 2. So I'm going to do some of this in my head here. So we're going to take 2 to the 4th, so that's 16. So we're left with 3/4 times 16. Oops, didn't want to close the parentheses there. Okay, then minus 1/3 t cubed, so 1/3 times 8. Okay, cool. So that's our first part. Then we'll subtract it and evaluate at -1. So evaluating at -1, plugging in -1 to t to the 4th will give us a +1. So that value is simply 3/4 minus, when we plug in -1 here, we'll get a -1 times that 1/3. So we'll have a -1/3, so I'm just going to change that to a +1/3 there since it was minus and negative. Cool. Okay, let's keep working through. So we have that 1/3 all the way out in front. From here, it's just algebra, right? So this is going to be, I can cancel that to a 1, and this becomes a 4, right? So this is really just 12 minus 8/3. And then 3/4 plus 1/3, right? If I want to get a common denominator of 12, this would be 9/12. Oops, 9/12. And this would be 4/12. All right, keeping on the algebra train here. All right, 12 minus 8/3, we can write 12 as 36/3 minus 8/3, and then the 9/12 plus 4/12 is 13/12. So we're subtracting 13/12. All right, so I'm gonna do this part first here. 36 minus 8 is 28/3. And this is 13/12. I want to write them as a common denominator, so I have to multiply 28 by 4. I'm doing this without a calculator here. In real time. Okay, great. So this is really 112/12 minus 13/12. So that's 1/3 times, if we subtract, we'll get 99/12. All right, so we're multiplying 1/3 times 99/12, so I can cross cancel. So this becomes divided by 3, this divided by 3. So we have 1 times 33 over 1 times 12. That can simplify. We can divide them both by 3. Cool. That was one I also got from AP. I got all of these from AP Online. Well, I made one up, but this is another one I got from there. So yes, it seems algebra heavy, but yes, it was a no calculator problem from a past AP test. So in all reality, the calculus of this problem was done like here. We were done with calc. This is all algebra. Cool, so 11/4 is our answer. Let's move on to our next problem. All right, this third example is not necessarily asking us to find the average value. In fact, it tells us what the average value is already. It's asking us for a different part of the puzzle. So here's what I would do. Here's what we're given. We're given the average value of f. We're given our bounds here, and we're given what the average value equals. So here's what we know. We know that when we find the average value from -2 to 4, okay, so how do we write that? Well, we write that like this. 1 over 4 minus -2, which is 6. So 1/6 of the integral from -2 to 4 of our function. That's the average value. Well, we know what that equals. That equals 12. That's what we know. The problem gives us that. It's asking us to find this right here and then it wants us to divide it by 8. You know, really, this right here, what we're asked to find, could be rewritten like this. 1/8 out in front of that integral. So if we find this integral here, which we can from this problem, right? Just a simple multiply by 6 on both sides. Once we find that, then we can multiply by 1/8 or divide by 8 to find our answer. So this problem is actually easier. It's just more algebra and more extra thought, I think. Okay, so we have this now, what we're given. So what I'm going to do is get rid of the 1/6 by multiplying by its reciprocal on both sides. Right, so here's what we know. We know that the integral from -2 to 4 of our function is 72. Well, that's not quite answering the problem yet because we want to know basically what that integral is divided by 8. We want to know what 1/8 of it is. So if we divide both sides by 8, then we have the integral of f of x over 8 dx is 72 divided by 8, which is 9. So just kind of an alternate way of thinking about something. These problems look trickier than they really are, but just think about, what is average value? How do we find it? We basically just use the definition that we learned at the beginning. We had an equation, so we could solve for what we wanted here. All right, on to the last example. Okay, this is the one that I made up, trying to come up with some tricky and cool substitution problem, but it worked out okay. It didn't work out as well as I wanted it to, but it's still a good practice problem. So here we go. We want to find the average value. So again, pretty straightforward. So finding the average value, we take 1 over b minus a, so 1 over 2 minus 0, so half, of the integral from 0 to 2 of our function x times the square root of x squared plus 2 dx. All right, so that's essentially what we need to solve. It's straightforward fundamental theorem of calculus. Let's just do it. The problem is that we need to use substitution. So take a second to think about what your u substitution should be. All right, we should have u as x squared plus 2. Therefore, du would be 2x dx. We need to use u substitution here because we can't just straightforward do the integral, or the integrating rather. Okay, solving for dx. dx is du over 2x. All right, let's plug that stuff in. So we'll have 1/2. And then I'm going to start to get stuff in terms of u here. So I'm going to wait to write my limits of integration. So I have x. And then I have the square root of u, since I replaced it. And then dx is du over 2x. So what happens is our x's will cancel, right? And then so we're left with 1/2. But then we actually have, so I'm going to erase that. We actually have another half here, right? Dividing by 2 here. So I'm going to bring that out in front and multiply it by the original half. So we'll have a 4th out front, just keeping constants out front. And then I have u to the 1/2 du, since the square root is a 1/2 power. All right, now I want to rewrite my limits of integration in terms of u. Again, you don't have to do this. If you want to just write x equals 0 here and x equals 2, that's okay. But I'm just going to rewrite them in terms of u. So when we do that, if x was 0, what's u? Well, I plug in 0 here. So 0 squared plus 2. So that means this new bottom limit is 2, our lower limit's 2. All right, let's try the upper limit. When x was 2, what would u be? Let's plug it in here. So 2 squared, 4, plus 2. So our upper limit in terms of u is 6. Great. Now we can integrate. So we'll have 1/4, and then we have to do our integration. So we'll add 1 to the u and divide by that value. So that's 3/2. So we'll divide by 3/2, which gives us 2/3 u to the 3/2 from u is 6, or 2 to 6 rather. Okay, if you want to make this simpler, we can multiply the 1/4 and the 2/3 instead. So doing that, I can cancel. So I'm left with 1/6. Then we can evaluate the u to the 3/2 at 6 and 2. Okay. So let's plug in. We have a 6th out front. So then we're going to have, remember, 3/2 power means this. Right, it means a square root and then you cube. So we can rewrite this here as the square root of 6 cubed minus the square root of 2 cubed when we evaluate. All right, so next, the square root of 6 is 216. I'm sorry, that was not right. 6 cubed is 216. 2 cubed is 8. And then let's just break down our roots, right? We'll simplify. So 216, I did this just a minute ago. I think 216 is divisible by 36. That's its biggest perfect square that fits in it. So this can be broken down as root 36 times root 6, since 36 times 6 gives us 216. So this breaks down as 6 root 6. The square root of 8 can be written as root 4 times root 2, so 2 times root 2, and then we are done. The one on your AP Online assignment, the roots are like terms, like these would be the same, and then we could combine them. This is one that I made up, so it didn't work out as pretty, but still the same idea. So this is our final answer. Again, a no calculator problem, but looks pretty good. Alrighty, here is your homework for today. It is an AP Online assignment found here called 8.1 assignment, average value on interval. It is 5 multiple choice questions that are no calculator problems, due by tonight at 11:45 p.m. Have fun.